CFOP is an intermediate to advanced method of 3x3 in which you solve a cross and then you do F2L, then OLL, and then PLL. If you don't know what this means, let me break it down for you. Alright, so the first step is called the cross. So this is the cross. I made an X cross also. So an X cross is basically a cross with an F2L pair inserted into it. This is an F2L pair, and it's the one that I put in, yes. But this is the F2L pair. So basically, this F2L pair is basically a white corner with the corresponding edge piece attached to it, and this edge piece will be an edge piece in the middle there that goes along with this, as you can see. So I would just insert it, and then I just do it throughout the whole slots and the second layer, and then I'm done. First and second layer, and then I'm done. So next is OLL, in which you have to apply 1 to 3 algorithms. One algorithm if you get a cross, because I'm going to be teaching you 2-look OLL, which requires 1 to 3 algorithms. In one case being the best because you already got some skips, which basically means an algorithm has already been done for you. A step has gone missing, which is great. It's not like you missed out on something. You get ahead of something. You don't have to do something. So yeah, this is the next step. And then you apply 1 to 3 algorithms. In this case, I need 2 algorithms. So I'm just going to do 1 and then 2. Now we're at the next step, which is PLL. So in this case, you can apply, again, 1 or 2 algorithms, 2, not 3, 2 algorithms. I'm going to be teaching you the 2-algorithm method, which is 2-look PLL, but there's also a method called 1-look PLL, where you have to learn 21 algorithms. If you think that's a lot for 1-look OLL, the last step, you need 57 algorithms. But these numbers can just sound daunting, but they're actually not that hard to do. That's because when you look at the algorithms, you realize that there's a lot of repetition in them, a lot of the algorithms are mirrored, and a lot of the algorithms just have right-hand algorithm or something that is just key and really basic and just makes the algorithm much easier to learn. So in this case, I would need 2 algorithms. So I would just do this once, and then, which is a T-perm, which I just did, and now I just apply 1 algorithm. This is called a UB-perm. All these PL algorithms are called perms. I don't know why, this is not a haircut video. And then you just do 1 algorithm, and then you're done. So you can get a PLL skip, what I mean is a half PLL skip, not a full PLL skip. You can get a full PLL skip, but let me just show you something. Yeah, so there's a first step, which is already, so let's just say I'm just doing this. I did my OLL algorithm, and then I got here. Now here, I already skipped that first step of doing either T-perm or a Y-perm to get this step. So now I can just do 1 algorithm. So I would just call this a half skip. I don't know if that's an actual word in cubing, but here I would just do 1 UB-perm to get the final result. So let's get into it. I'm going to show you how to do CFOP in this video. Now I'm going to scrub on my cube with the trusty CS Timer website. So I'm just going to be doing this scrum. F, U2, R2, B, U2, B, L2, R2, U2, R2, F2, L prime, B, D2, F, U2, R2, F prime, R, D, F. Alright. Now we're going to be doing white cross. So make sure that is on the bottom. So in CFOP, since you want to be quick, you have to plan out the most efficient strategy for cross as possible. You want to spend the least amount of time on it. Here, what I would do is, I know that orange and red are opposite. So if I do a D2, this will align, but I can make use of that. I know that blue is opposite green. So if I put this here, and then I do a U2, this perfectly matches up. So, yeah. So now what I'm gonna do is I'm gonna make use of that, and now I'm gonna just put that in, and then I'm gonna do an L2, a U prime, and a B2, which creates my cross, and then I can do a D2 and align it. So you should be able to do this no problem. You should be able to construct a cross. If your cross isn't the most efficient right away, that's fine. You can always work on it later. Alright, so the next step is F2L. Alright, so in F2L, I'm first gonna teach you what a pair looks like. So forgive me for being a bit slow here, but I'm kind of in an uncomfortable position right now. So now this is how an F2L pair looks. It has one white, or the cross color. I'm just gonna say white here because I'm doing the white cross. So one cross color, and if you look from the cross, not in the cross layer and not in this layer, but here in this layer, and you find the other two colors. Here would be green and red, and then you find a red and green edge piece, and then attach the corner piece to that edge piece. You get something that looks like this. Now you might have something like this or like this, but I'm just going to show you algorithms that'll change that. Like from here you can get here, but yeah, so this is how an F2L pair looks. This is not an F2L pair. The pieces are in the correct position, but this is turned, so this is not correct. So here I would just insert this like any other corner, and then I would move on. So there's quite a few algorithms, and if you want to achieve a 20-second time, you should be spending 10 seconds on this, which can sound pretty fast, but it's not that hard to do. So you just go all around, and yeah. So, sorry. You just do that all around. I'm not going my fastest right now. And then F2L is done. Let me show you how to do that right now. So, the first thing I'm going to be talking about is how to insert a corner. So, how to insert a corner should just be natural to you, but still I'm just going to be showing you anyway. If you want to insert something like this, an F2L pair, here you need to do F R prime, F prime R. Let me just one thing here. If you want to insert something here, all you need to do is R, U prime, R prime. And of course you just fiddle with the top layer to get the case that you want. If you want to insert something here, let me just get this here, and now I'm just gonna take this out. This out here, all you need to do is L prime, U, L. If you want to insert something, this here, L prime, U prime, L. If you want to insert this here, F prime, L, F, L prime. Alright, so now you know how to insert corners. There's some more advanced stuff, like when you build a pair, inserting it into the back like this, but I'm not gonna confuse you with that yet. So if you have an F2 pair, now you know that you use the Euler to bring it to the front, and then you insert it to this. The next step is OLO, but I'm not going to go into that right now because there's a lot more cases than just already made F2O pairs. So the next case is if you have a case where on the right side of your edge piece, and remember your edge piece would be on the Euler, or it can be inserted like this, in which case you have to just bring it out like this, the same way you would bring a corner out, just easy like this. Or if it's on the other side, imagine this one was turned like this, then like this. So yeah, you bring it to this layer, and then all you need to do is position this corner. Remember, this would be on the right side. I'm only going to be talking about the right side for the moment, not the left side. So basically, this case, when this is on the right side of the edge piece, and this has to be turned clockwise once to make this like a proper F2O pair. So all you need to do is position this corner on top of the F2O pair, an open F2O pair slot. Just put it on the one that it needs to go into. That will always be free, and just do this algorithm. This is the right-hand algorithm. R, U, R prime, U prime, R, U, R prime, U prime, and then just insert like the corner. Insert it like a corner. So now let me just show you the same thing here. So here, all you need to do right here, when it's on the left side, it needs to be turned counterclockwise once. Do the same algorithm on the left side with the same principle that this should be over a unsolved slot. So this should be over an unsolved slot. This one you don't care about, over an unsolved slot, just the corner. And then just do the left-hand algorithm, which goes like this. L prime, U prime, L, U. Just do that again, and then just insert it like any other corner. However, if your corner looks like this, where you have to, if it's on the right side, just do this counterclockwise once to get a proper F2O pair like this. Then do this. Position this corner. Let's make a line that goes back from the corner, like this. Not like this, where this edge piece is in, not like diagonal, just a straight line from edge piece back. Now, imagine this back corner. Now you want to bring this back corner above the slot. Now you turn it so that this corner is here, and all you need to do is reverse right hand, which looks like this. R prime, U, R, U prime. Just do it again, and then you can just insert it like any other corner. So when I said insert it like any other corner, it would already be solved, and then I would just insert it into the back like that. So same principle on the left side. Let me just fix this for a sec. Yeah. Here, I would just make this line. Here, put this one in the back, and then just do left hand reverse. So now I would do L, U prime, L prime, U, and then just do, do that again. And now I can insert it into the back right here like any other corner, and then I would be done. Remember 1, 2, 3 algorithms in the OLO, which can be kind of frustrating. I have to edit this part out to make a mental note of that. So now there's a lot more cases still. So I'm just going to be teaching you a quick trick, and now just before the trick, I just need to So now I'm just going to be telling you just a couple more cases that you could get. So the first case is a case that you might see and know if you're beginners. So I'm just going to turn it like this, and remember this case? Sorry for my horrible wrist turns. I'm just trying to be a bit of a noob here. And now I do this. Did you realize when you did that, you made an F2L pair and then inserted it like a corner? Yup. So all you need to do is find, if you have a corner that's inserted already in the correct spot, and then you have, it doesn't have, if you have a corner that's inserted into the cross, and then you have just this, and then it's turned properly, like here it's turned like this. If it would be here, it would be turned properly like this. Then all you have to do is just simply solve it like you would in the beginner's method. So what I mean by this is, I'm just gonna flip it like this now to make it easier to understand. Of course, you do it upside down. So here, bring it away. Remember, take this one, the one that you want to bring here, like this, not like this, because this would be flipped if you inserted it. And then you bring this outwards from the direction that you want to put it in. If you would be here, which it's not, because it's flipped, imagine if this was flipped, then you'd go like this. But here you want to go the other way, and then bring this down. This down, meaning this one down. Not like this, because if you bring this away like this side, then you bring this side down. If you bring this away this side, then you bring this down. When I say this, I mean, again, if this was flipped and then you bring this here. So now you bring this away, down here, up, and then you solve it. If that's a bit confusing, sorry. Alright, so the next case is, so basically, if you have a corner like this, then all you need to do is solve it like you would in beginners. So if it's here, if it looks like this, or I don't know, if it even is here, and then it looks like this, I'm just gonna do it here since it's just easier to understand. Then all you need to do is bring this in the outer layer, or you can just solve it like you would in beginner's method, and then it's solved in. So the next step is learning about conjoining pieces to make the F2L pairs. So imagine if you have something like this. All you need to do is this, and then your F2L pair is inserted. Same story here. All you need to do is this, insert it. But how do you insert like that? How do you bring pieces out into the top layer? Well, all you need to do is, if it's on the right side, if it's on the left side, that's all you need to do. And if you want to bring them back, that's all you need to do. Here, if you want to bring them back, that's all you need to do. So, when I say back, I mean back from this top layer. So, let me just show you some examples of that. So, here, this isn't proper, so I want this out in this place. So what I would do, I would just bring this edge piece so I can just connect them while I bring it outside. if it would be on the left side, then I would do the same thing. Imagine this was this piece. I would just connect them like this. So imagine here, I would connect them like this. And now I can just use that flipping algorithm and then just insert it. So now on this side, I'm just going to demonstrate the same thing again. I would bring this outwards and then use the flipping algorithm and then insert it. Alright, so I will leave link down in the description for F2L algorithms in case this was quite hard to understand, which I think it was. And sorry if it was, but yeah, just go to the description. I know a lot of good places for F2L algorithms, and yes. So now we're moving on to the next step, which is OLL. In OLL, you need 10 algorithms. So first, you need to make the cross. So, let me just start from the dot case. The dot case is the most annoying case in Tulip OLL because you have to put 3 algorithms to solve it to the next step. So the first algorithm is just the line case. So all you need to do is F, R, U, R prime, U prime, F prime. Now you'll get to this funny L-shaped thingy. Remember, we're only focusing on the edge pieces here. We're gonna focus on the other things when we make the cross. So once you're done with this, all you need to do is apply that same algorithm, but when you apply the F's, you just want to do 2. Like this. This was the previous F, and now lowercase f in the algorithm notation is like this. So you want to do this. And remember, you want to position this correctly. You don't want to position it like this and then do that algorithm. You'll get it wrong. You want to position it like this, facing bottom and right, and then do the algorithm. That might be why if you paused the video just before and you did that algorithm, it didn't work out for you. So the other cases that you might get are this case, which was that case. You just apply that algorithm and then you'd be done. And remember, you have to turn this U layer to how it needs to go so that you can do that. And you can also have this case in which you position it like this, and then you apply this algorithm. In this case, I would just, this is the OLL algorithm to solve this to the next step, which coincidentally happens to be the algorithm for this edge piece. So this is the first dot case algorithm, the first part in that. And once I did this from the dot case, I got to that L-shaped thing. So now what I would do is F, R, U, R prime, U prime, F. And then I get to this, and remember 1 to 2 PL algorithms, and then I would be done. So yeah, so I would just do this, and then I would get that case. So now we have to get to the corner orientation stage. So now this is the first, pardon me, it's not the first case. This is the first case that we're going to get. Now, forget about the positions of the pieces, just focusing on how the pieces are turned and how much yellow is there when you look at it from up. So if it looks something like this, like a little fish like this, and then you put this fish thing facing southwest, and then you find yourself also having this this yellow facing at you from right here as you do it. Like if you position it like this, and then you find this, then you have to do the soon algorithm. For the soon algorithm, it's the same algorithm as orienting your cross. So here, what you would do is RU, R prime U, RU2, R prime, and then you would get PLL, which would be the next step. So the next case that you can get is anti-soon. So if you face it like this, the fish facing northeast now, and you find yourself with this facing at you here, this facing this side, and this facing this side. When I say this, I mean yellow, yellow, and yellow. And then you have this fish facing this side. Then what you got to do is anti-soon. RU2, R prime, U prime, R, U prime, R prime. Now you're done. So the next case that you can get is H. So in H, what you gotta do is, if you have two headlights here, F, R, U, R prime, U prime, and then you have to do this 3 times. F, R, U, R prime, U prime, and then you just do another F prime. When I said you gotta do it 3 times, I meant the right-hand algorithm. So F, R, U, R prime, U prime, R, U, R prime, U prime, R, U, R prime, U prime, F prime. But just to shorten it, in the algorithm, you would write R, U, R prime, U prime 3 to indicate that in the bracket of R, U, R prime, U prime, you have to do whatever is in that bracket 3 times. So now we get to the next step, which is called pi. So in pi, which is not my first, which isn't resolved around my first video, the cringy one. So here you just do this algorithm, which coincidentally happens to be my favorite algorithm. So now all you need to do is RU2. Remember, you position it accordingly. So you have to position it exactly how I'm positioning it, or your solve will be messed up. So headlights here, and then a yellow piece facing here. Same thing in the back, right, facing right there. All you need to do, RU2, R2, U prime, R2, U prime, R2, U2, R. Now you're done with that, and now the next case is called U. So my bad. So in this case, all you gotta do is position it so the headlights are facing you, and then you do R2D, RU2R, D prime, in this case, all you gotta do is position it so the headlights are facing you, and then all you gotta do is R2D, R prime, U2, R, D prime, R prime, U2, R prime, and that's all you need. And now the next case is T. So all you need to do here is you have this, I don't know what to call it, this box with an edge piece sticking out of it, and then you have these 2 corner pieces just sticking out in the front and in the back. All you have to do is do an X which is a cube rotation. So all you need to do is this, and then just do L, U, R prime, U prime, L prime, U, R, U prime, and then your OLL will be done. So now all you gotta do, this is the last algorithm, is L. L is the last algorithm. So all you gotta do here is do another X, R prime, U, R, D prime, R prime, U prime, R, D. And remember, so all you gotta do in this case is base it so that these two yellow stickers are facing you like this, and then just do this. And now just do R prime, U prime, remember the X, R prime, U prime, R, D prime, R prime, U prime, R, D. And then now you know all the PLL algorithms. Now we can move on to PLL, in which there are only 6 algorithms, and then we are done. So all you have now are PLL. Oh, I already said that. Instead of doing one algorithm, remember, now we just do 2 algorithms in a row, 1 or 2 algorithms in a row, depending on if you got to skip, or 0 algorithms if you get a PLL skip, which means that you can go from OLL right to the end of the solve. That's pretty lucky. So all those skips, OLL and PLL, you can even get an OLL and PLL skip. Those are incredibly rare. You can get an OLL skip, which is rarer than a PLL skip. You can get a cube skip, which is just kind of dumb. So now all you need is to do corner permutation and then edge permutation. So corner permutation, basically you just have to do a diagonal corner swap or an adjacent corner swap. And if you don't get what that means, it just means that you have to orient your corners to get a kind of funny looking thing. So you have to get it to look like this, where the edge pieces are just swapped out. Like this, the edge pieces are swapped, but the corners are in their proper position beforehand. Like this, corners are in their proper position. Corners are in their proper position, but the edge pieces are not. And then you just apply one algorithm to finish it off. So these last algorithms are called 3-edge cycle anti-clockwise, or UA perm, 3-edge style clockwise, which is the UB perm, opposite edge swap, which is the H perm, and adjacent edge swap, which is Z perm if you're Canadian, Z perm if you're not. So now, so let's get into this. So corner permutation. If you already have an H perm, a U perm, or a Z perm, Z perm or whatever, which looks like first this, second this, third this, fourth this, then all you gotta do is wait, because you're done with corner permutation. Now you're already in edge permutation, in which those are the 4 algorithms to learn. But now I'm just gonna be working on the corner permutation for those of you who are not done with that yet. Which of course you wouldn't be, because I haven't told you the algorithms for that yet. So, the first one is a Y perm. So if you don't have any edge permutation, and you have to swap these two to get all the corners proper, you don't have to swap these two, you have to swap these two. You see? these two are improper. You can see these are their own F2O pairs, but we need these two to be as well. So now this is yellow, blue, red, which belongs here, yellow, blue, red. And now this is yellow, green, orange, which is yellow, green, orange, belongs here. So you need to do a diagonal corner swap to fix this. So you want to put, you just want to face any direction. If you want to just solve the cube, you have to put it here if you have a y prime, which looks like this. If you don't, then just follow me. You also might have an adjacent corner swap, which I'm going to get to you in a second. So here, all you need to do is FRU prime, sorry, my bad. All you need to do here is FRU prime, R prime, U prime, RU, R prime, F prime, RU, R prime, U prime, R prime, F, R, F prime, and then you get to the wacky edge permutation state. Now, the next thing that you have to learn is something called a T-perm. In a T-perm, case here, all you need to learn now is a T-perm. In a T-perm, which is the adjacent corner swap algorithm, you would have one of those things which are like headlights, and then you have to position that in the left, and the rest isn't. And then all you need to do is a T-perm, which goes like this: RU, R prime, U prime, R prime, F, R2, U prime, R prime, U prime, RU, R prime, F. So then you're done with that. So now I'm at the last step of the whole cube process, which is PLL edge permutation. So now all you gotta do are learn 4 algorithms. So 3-edge dot anti-clockwise, which is the UA prime. That's what we're gonna do first. So that looks like this. So all you gotta do here is just simply position this solved layer in the back, and then just do this. Position this one on the right. How you recognize this, the colors are opposite here. If they're opposite on the left side, that's a UB perm, wait for that. And all you gotta do here is R, U prime, R, U, R, U, R, U prime, R prime, U, R2, and then you're done. Now, if you have the other case, which is called the 3-edge dial clockwise, which goes like this. This needs to be here, this needs to be here, this needs to be here. In the other case, this would need to be here, this would need to be here, this would need to be here in that case. So now all you need to do is, I'll give you 2 algorithms. You can pick one which is easier for you. The first one is R2, my bad, sorry, I'll just do that again. R2, U, R, U, R prime, U prime, R prime, U prime, R prime, U, R prime. So the next algorithm is M2, U prime, M, U2, M prime, U prime, M2, and then you're done. The next 2 cases are just pretty simple cases. So these 2 cases, the easiest is just the H prime, which looks like this. So this is a pattern. So these 2 are, there's just headlights all around. So, and opposite color headlights. So all you need to do is just on any side, it doesn't matter now. So just on any side, you pick any side, and then I'll just take this side, and then you just do this algorithm. M2 U prime, M2 U2, M2 U prime, M2. You can get pretty fast with this algorithm in just a couple of weeks. So the next algorithm is adjacent edge swap, which is a Z perm or a Z perm, I don't care. So now all you need to do here is M prime, U prime, M2, U prime, M2, U prime, M, U2, M2. So make sure you position it like this, where this is ahead of you. So if you have these two like this, where this is a headlight, but they're not related. And when I mean they're not related, take a look at these two. These two need to be swapped. So these two don't need to be swapped like this. So find which ones need to be swapped here and here. So you need to swap like this, and then just find the front one. And when I mean the front one, I mean that the thing that it needs to swap with is on the right side of it. So now all you need to do is that algorithm, and then you're done with the cube. Give yourself a pat on the back. Thanks for watching.